Alright guys, sorry, my iPad died, so we don't have very much time for this, because it's probably going to die again really soon. But we last left off, we wanted to know which one, propane or benzene, would produce or give off more heat. So which one would produce the most heat? And that we wanted that to compare it between 1 gram. So I had 1 gram of propane, 1 gram of benzene, and I know that propane, 1 mole of propane could release 2,200 kilojoules of energy, and 1 mole of benzene could release a 3,267 kilojoules, but I want to do it in kilojoules per gram instead of kilojoules per mole. So we can use molar mass, and that's what I set up here. So molar mass for propane is 44.1, for benzene is 78.1. So if I did the math here, I would find that propane would release 50.3 kilojoules in that 1 gram, and benzene would release 48.1 kilojoules per, that's not mole, that's gram. Kilojoules per that 1 gram. So if I wanted to compare which one would be better in terms of 1 gram, which one would produce more energy, I would definitely say propane would. Okay, let's go back then to our PowerPoint. So this one, guys, remember I wanted you to try that on your own, and I gave you that answer. This one we just did together. In terms of energy and foods, the last section in your chapter is just kind of combining foods and energy. So most of the fuel in the food that we eat comes from carbohydrates and fats. So this table in your book has the different values for fuel of some common foods that we're eating. So in terms of carbohydrates, in terms of fats, and in terms of proteins. And then it's telling you and how many kilojoules per gram is that fuel. And then remember we have that kcal per gram for the fuel value. So this is just something that is comparing our amount of fuel that we eat in some of these foods. Okay, again, energy and fuels. The vast majority of the energy that's consumed in this country is coming from fossil fuels. And in 2008, the United States consumed 1.05 times 10 to the 17th kilojoules of energy. And that corresponds to an average daily energy consumption per person of 9.4 times 10 to the 5th kilojoules. So that is so much energy that we are consuming just from the United States alone. Although the United States is only 4.5% of the world's population, we as a country account for almost 20% of the world's total energy consumption. And that is just, it is just crazy. So for us, we definitely take in or consume as a country a ton of energy. Okay, that is the end of our PowerPoint with thermochemistry. Again, on Monday, we're going to take time in class to just go over and review, I think, all of these concepts. I want to give you some more practice problems. I will post on your blog, like I said, some practice multiple choice questions, a practice maybe free response question, and I'll post those answers as well that go along with it. And then your test multiple